All right, in this video, I'm just going to do one more truss. I'm going to do the last one of the worksheet that we started in class. So that's this one here. I've gone ahead and already drawn it just to save us a little bit of time. I'm only told it's 45 and 60, and there's 3 feet. But since it's 45 there, we know it's 45 there because it's a 45, 90. So these things are both 3 feet. Since this was 60, that has to be 30, so it's a 30, 60, 90. I know it's not drawn very well to scale. And since that was 3 feet, this becomes 1.7 feet from your 30, 60, 90 rules, or you can use your trig functions to solve for that. And it had the load of 500 pounds. So first we're going to determine we're going to decide or calculate if it's statically determinate. Okay, so remember that is 2j equals m plus r. J is the joints. We have A, B, C, and D, so there's 4 joints. The members are the things between the joints, so there's 1, 2, 3, 4, 5. And then reaction forces, we haven't put those on there, but if we looked back here, we have a pin and a roller. And so a pin has 2, one perpendicular to the surface, one parallel to the surface, and a roller has 1 that is perpendicular to the surface. So the pin and the roller, 2 and 1 respectively. And so that makes 3 total. So 2 times 4 is 8, 5 plus 3 is 8, 8 equals 8, so we are statically determinate. So we can continue forward with this thing. So now we're going to solve for these 3 reaction forces. I'm going to label this one reaction force at A in the x direction, reaction force at A in the y direction, and reaction force at B in the y direction. We have our 3 equations because we have 3 unknowns that we need to solve for. So when we're solving for the external forces, we're going to use the sum of the moments is equal to 0, the sum of the forces in the x direction is equal to 0, and the sum of the forces in the y direction also equal to 0. Okay, looks like my pen's about to give out, so I'm going to jump to a different color. Okay, so we're going to start with this one here. We're going to pick the point to rotate around that has the most unknowns. Okay, so we're just going to pick the pin. So the sum of the moments about point A is equal to 0. Because the distance for both of these, moment equals force times distance, distance equals 0. So both of these disappear in this equation because they're just 0. So we move along. We have this load of 500 pounds. And this 500 pound load is going to cause me to go this way, right, which is clockwise. So that's a negative. So we're going to have a negative. The force is 500 pounds. And the distance from this point is 1.7 feet. Okay, then we're going to go to the next force that causes me to rotate, which is this one here. It's going to cause me to rotate around that point this direction. Right? So going around that direction, which is counterclockwise. Counterclockwise is a positive. So we're just going to add that on. And now it is RBY, that's the one we don't know, that's our unknown, times its distance. Well, it's 1.7 to here, and then 3 more to there, so that's 4.7 feet. We're solving for RBY, so we're going to add this to the other side and end up with RBY times 4.7 is equal to the positive 500 times 1.7. Okay, because we added it to both sides to get it to the other side. Now we're going to divide by the 4.7, and that gives us that RBY is equal to 500 times 1.7 divided by 4.7, which will be, by the calculator, 500 times 1.7 divided by 4.7, 180.85. Let's just call that 181. We'll just round things off to the nearest whole number. 181 pounds. So that's RBY. We got a positive answer, so that means we guessed correctly in the direction of our force. So 181 pounds. Now that we've done that, we still have 2 more equations that we can use to solve for our other 2 unknowns. Okay, so that was the first part. So now we're going to do the sum of the forces either in the x or the y. Since x is next, let's just do him. In the x direction, what do I have? I have RAX. Now there is no force times distance, it's just forces now, it's not moments. So there's no distance, we don't care about the distance anymore. So that's the only arrow going in the x direction, so done. RAX is equal to 0. Okay. So now we can go to the sum of the forces in the y direction. Also equal to 0, but in the y direction we have quite a few. We have RAY going up, so he's positive. We have 500 going down, so he's negative. And then we have RBY going up, so I'm just going to go ahead and put the number in of 181. Okay, now I'm going to add 500 and subtract 181 to say that RAY is equal to 500. We added to the other side minus the 181, which should be 319, but let's get our calculator just to make sure I'm doing things right early in the morning here. And it is 319. And we're working in pounds. And so we know, and we got a positive again, so we guessed correctly on this. This will not always work out like that. So just be careful as you're working these things. Now the next part, and I'm going to go to another piece of paper. We've solved for all the external forces. We know everything about this truss and how it reacts to the outside world. We know all the distances, we know all the angles, we know all the forces, we know which direction they would cause us to turn if we rotated around that point. Really, we just got to move forward now to solve for the internal forces on each joint. Okay, so when we do this, we're going to take this and we're going to redraw this thing. So this is joint C. Okay, this is joint A. Then we have joint D right down here. And then we have joint B, which is over here. Now, when we draw these, it's kind of like you're redrawing the truss, but you don't connect the lines between the two. And then you just put arrows on all of them. Oops, forgot that one. So they're probably not lined up perfectly, but you get the idea. And so there is our free body diagram of each joint, but we've got to remember to put back these forces because they do act on us. We have RAY, okay, equal to 319 going up. This one really doesn't exist, okay, so we can really just ignore him. I mean, he was kind of there. It's not really going either direction because he was 0. Okay, so we can really ignore that. I'm going to write him on there because he did exist, and sometimes he will be there, so we don't want to forget about him completely. We have our 500-pound load going down there, and then we have our BY of 181 pounds over here. We also know those angles, right? We knew this was 60 degrees. We know this is 30 degrees. We know this is 45 degrees. We know both of these are 90 degrees. And we know this is 45 degrees. Now in this part, we don't use anything with moments, so we don't really care about the distances anymore, and we cut them off anyway, because we're looking at each joint individually, one at a time. So to start off, we just need to pick a joint that has the fewest number of unknowns. Okay, so this one up here has 3 unknowns. This one down here has 3 unknowns. This guy has 2, and this guy has 2. So we're going to pick either A or B. The next criteria, if you have 2 that match, is try to pick one that doesn't have any angles. This one doesn't, but he had 3 unknowns. So we can't really work with him yet. So we got to go to one of these. They both have angles, so it doesn't matter. Let's just go alphabetically and start with joint A. Okay, so we're going to start working with joint A. So that means we're going to ignore that these even exist over here. We're only looking at this joint right here. We only have the 2 equations now, the sum of the forces in the x equals 0 and the sum of the forces in the y equals 0. And we only have 2 unknowns, right? What 2 unknowns do we have? We have this force called force AC because it's the force going from A to C. And we have this force right here that is force A to D. So those are the 2 forces we are looking for. 2 unknowns, 2 equations, we're good to go. Now we know something in the y direction. We really don't know anything in the x direction. It's kind of like there's not a force there. So I'm going to start with the sum of the forces in the y because we have a known in that direction. So the sum of the forces in the y is equal to 0. And now we have to add up all the forces in the y. Well, we have RAY going up, so he's positive. And then we have this guy going at an angle. Angles are no good for us. Okay, so we need to do this stuff. And so now we're going to have this force AC in the horizontal x direction, and we have this force AC in the vertical y direction. Because we can't deal with that angle. Okay, we'll have to come back to him to solve for him, but first we have to solve for the vertical and horizontal parts. Okay, so this is plus force AC in the y direction. Now, we can solve for that, and we can say that RAY is equal to negative force ACY, but we're looking only for force ACY. That's my unknown, so I'm going to make him the positive. So I'm going to subtract the RAY to the other side. So I'm going to say force ACY is equal to negative RAY, which is equal to negative 319 pounds. Now, negative means we guessed wrong, but we really haven't found the force we're looking for, so let's not switch things yet. Wait till you get the actual force, not this component that we're looking for. So we got to find FAC, that's my real unknown, based on this, okay? But based on this triangle, I know that this is 30 degrees or this is 60 degrees. So I know both angles, I can use either one. I'm just going to use this one, it's right next door, so I'm going to use the cosine function. So I'm going to say that the cosine of the angle is equal to the adjacent, FACY, over the hypotenuse, that's the FAC that I'm looking for. I'm going to solve this for FAC. Right? I'm going to multiply both sides by FAC and divide both sides by cosine. So these things kind of flip-flop spots. And now that I have FAC, based on this, I can go back here and solve this because I can say that FAC is equal to FACY, which is negative 319, divided by the cosine, and the angle I was using was the 30 degrees. So I have my negative 319 divided by the cosine of 30, and I get 368.3. Let's just call that 368. Now it's a negative, so the magnitude is 368 pounds. The negative told me I guessed wrong up here. This guy should not be going this way, but he should be coming back this way. So he's not in tension pulling, he's in compression pushing. But I know force AC is 368. Okay, so that's my value, and the direction is compression. Now the thing, I'm just solving for this down here, but because these two forces are the same force because it's on the same beam, once I find this, I can go ahead and use it for this joint as well. It's the same force throughout. So when I do that, it's the same value, I just have to change the direction because it's the same beam. You can't go halfway through a rope, a beam, or something, and all of a sudden have it change directions. You're either pulling on the rope or you're pushing on it. Okay, pulling on the beam or pushing on it. Okay, so we solved that. Now we're really still working just on this joint, right? Because we've only solved one of those. We solved for force AC. But we also have force AD down here. So let's look at the sum of the forces in the x direction. It's also equal to 0. Okay, in this case I have force AD going to the right. Okay, and I have force ACX. Now he was going to the right, but I just flip-flopped everybody. I just said they're going that way. So now it's kind of like they're going the other way. So I got to flip these guys as well. Okay, because I started here, so that didn't work. Started here, I'm going that way. So really it's like I have a minus, because he's going to the left now. Force ACX. Okay. What this tells me is when I subtract that force AD that I'm looking for is equal to force ACX. So I got to find force ACX. Well, again, I'm going back to my triangle. If I stick with this 30 degrees, now I'm going to use the sine function. So the sine of that 30 degrees is equal to the opposite side, the FACX, over the hypotenuse force AC. I'm looking for force ACX in this case. I know force AC, right? I just solved for him. So I can say that force AC times the sine of the 30 degrees is force ACX. Okay? Which is I'm looking for because force ACX is force AD. So that all works out. So let's rewrite this thing here. So force ACX is equal to force AC times the sine of 30, and that's still equal to force AD. So all I did was replace this with that. Okay, force AC we just solved for was 368 times the sine of the 30 degrees. So 368 sine of 30. And we get 184. And it was positive, meaning we were correct. We reversed it. If we wouldn't reverse it, it said, hey, you're still wrong because we forgot to reverse it, which told me it's still going down. But it seems like, oh, reversed it, we're going to flip it back. So that's why you got to remember, once you do one thing, you got to change it so it works correct for the rest of them. But that's force AD. Okay, getting a little crowded in here. It was 184 pounds. But look, force AD is also this force. So now I've solved this and that. So I can move forward now because I've solved some things. So these things that had more unknowns. And I could jump way over here if I wanted to. And I could solve this guy because he only had 2 unknowns. But now if I look at this, I know him, so I only have 2 unknowns here. And up here I only have 2 unknowns. So all 3 of those, I can pick any one of them now. Okay, since they're all kind of equal, but this guy has no angles and I don't have to deal with that trig, I'm going to jump to joint D next. Okay, so let's go to joint D. In joint D, let's ignore some of that stuff there. Okay, so in joint D we have these 3 things. We're still using those same 2 equations, some of the forces in the x and the sum of the forces in the y. Okay, we know something in the x and we know something in the y, so it doesn't matter which one we go forward with. So let's do the sum of the forces in the x is equal to 0. In the x direction, we have force AD going left, right? Because that was positive, so it's in tension. So we have 184, which is positive, negative, because he's going to the left. And then we have force, what's this force? This is force BD, or DB, doesn't matter which way you put it. But he's going to the right. But that's the force we're looking for. So what this tells me is I just add this to the other side and say that force BD equals 184. Well, that was easy. And because it was positive, that means intention was correct. We don't reverse any arrows. Okay, so now we can move forward with the sum of the forces in the y. See, it's much nicer if you don't have to use the trig. So that's why we try to get to these ones that don't have angles first. So in the y direction, what do we have? We have the negative 500 of the load, and then we have force, what is this? Force CD in the middle here. Okay, so force CD is equal to, we don't know yet, that's what we're looking for, but he's going up, so he's going to be a positive. We're going to add the 500 to both sides and say that force CD is equal to 500 pounds. So now we can say this is 500 pounds. So that one was easy. We love those. Okay. And look, what have we solved so far? We've solved that one, that one, that one. What all we have left? We only have one left. Force BC out here. Okay, so we've only solved 2 joints, but we've solved 4 of the 5. So it looked like there were 10 arrows that we didn't know about. 3, 6, 8, 10. But really, since they are the same on each side, there's really only 5 unknowns. So it's not as terrible as we thought. Okay, so now this last one, we've got a choice of joint C or joint B. In joint B, I have 1 unknown. In joint C, I have 1 unknown. In joint C, I have 2 going at angles. In joint B, I only have 1 going at an angle. So I'm going to jump to joint B because I think it's going to be easier because there's only 1 thing going at an angle. Okay, so we're going to look out here at this guy. Now we're looking for force BC. He's at an angle again, so we got to do this stuff. Okay, so we're going to have force BC in the x direction and force BC in the y direction. Now we know this guy down here is 184. We know this guy here is 181. Other than that, it doesn't matter. So we can use in the x or the y because we know something in the x and the y. So it doesn't really matter. We also know this right here is the 45 degrees, right? So let's just do cosine and do the sum of the forces in the y. You'll get the same answer if you do in the x. Okay. So in the y, we have RBY going up. Okay, so we'll just type in our number here. So 181 is positive. And then the force BCY, because right now we have him going up, is also a positive. But we don't know him. Okay, we can say that force BCY is equal to negative 181 pounds. Okay, because we subtract that to the other side. But that doesn't help us because we want force BC. So we got to look at our trig function here. We were using this cosine, so the cosine of that angle is equal to, I guess it doesn't matter if I do it in the light blue, cosine of the angle is equal to, cosine is adjacent, which is the force BCY, over the hypotenuse, which is what we're looking for, the force BC. We're going to solve for force BC by multiplying it over and dividing by cosine. So they're just going to change places. So force BC is force BCY over the cosine of the angle. Right? Well, we know force BCY. So we can say that force BC is equal to the negative 181 divided by the cosine of the 45 degrees. So negative 181 divided by the cosine of 45 degrees. And we get 255, so let's call it 256. It's a negative, so it's going to be 256 as the magnitude. Okay, so force BC was 256 pounds. Okay, but the negative told me I guessed wrong on the direction, and so I got to get rid of the arrow going that way and put it back going this way. And since it's the same up here, this is just the same beam, I have to switch it up there. I would also need to switch it on these. Well, it doesn't matter if I do that because I've solved for this, so there's nothing else to move forward with, so I don't need this anymore. I'm done, really. The last thing, the only thing I have not done as I went through, I changed the arrows, but I never said if it was in compression or tension. And so when you do your final answer up here, you're really supposed to put whether things are in compression or whether things are in tension. Okay? The arrows that are pulling away from the dots that we originally started were in tension. These didn't change, so this is in tension. So we're going to put a T with it. Same with this one, he's in tension. Now for these two on the outside, remember we changed the arrow direction, and so these things are now in compression, which is the opposite of the tension. Right, it's pushing. And this guy in the middle, we didn't change, he's still pulling, so he's in tension. And now we have solved, I know it's a little cluttered in there, but we have solved the forces that we're looking for. So let me circle them here so we can see. So we have force AC, we have force AD, we have force CD, force BC, and force BD. Those are my 5 internal forces. It's their magnitudes and their directions, compression or tension. Okay, and in the beginning we have all the original stuff with the external forces and the load. So now we know everything about my truss. And that's it.